Hello everyone, you are watching my YouTube channel Chemistry by Saad. Let's try to solve this past paper question. This is from AQA A level chemistry, equally important for OCR chemistry as well. This is Proton NMR relevant question. The statement of the question is given here. The Proton NMR spectrum of C3H7ClO. This is given here. The table below shows the chemical shift values and integration values for each peak. Chemical shift value is given here. Integration value is given here. First, we need to find out integration ratio. So let's try to find integration ratio. You see 0.6 is given here, then 0.6 is here, and 0.9 is here. We need to divide this by the smallest number, which is 0.6. So I'm going to divide each number by smallest number. So this is 1 ratio 1 ratio, and this would be 3 upon 2. Now we need whole number. So we multiply this with 2, multiply this with 2, multiply this with 2. This will cancel out. So 3 ratio 2 ratio 2. So integration ratio is 2, 2, and 3. What does this mean? This means this 2 represent I have 2 proton here attached with carbon. This 2 represent I have 2 proton attached with carbon. This 3 represent I have 3 proton attached with carbon. So this is the longest peak, the largest peak. This is CH3. And there is no peak splitting, no peak splitting, right? It means with this CH3, there is no adjacent proton, no adjacent proton, no peak splitting, so no adjacent proton. While this peak 3.65, this is because of CH2. This peak 3.95, chemical shift is 3.95 ppm. So this is again CH2, and both CH2 are adjacent to each other. Now let's use a data booklet. In this data booklet, so one peak is at 3.95 triplet. So where is 3.95? 3.95 comes here under this. So it means this should be the possible structure RCH2Cl. But we have a CH2 and Cl. So I will choose this as a fragment. Then the next is 3.65. So 3.65 should comes here, either this or this. So if I choose this, then ROCH2. So this would be a structure, and now here I should attach this CH2 with this CH2 because both CH2 are adjacent to each other. Then chemical shift is 3.35 ppm, and it is singlet. So it means I need to pick this because oxygen is there as well. So this is OCH3. So my one fragment is OCH3, my one fragment is this, and my other fragment is this. Let's combine all of these three fragments. So first fragment is OCH3. So I attach OCH3 here. Now I need to attach here this CH2. This CH2 is with O. So here I put this CH2, then this CH2, and then this Cl. So this would be the possible structure. CH3O, CH2, CH2, and Cl. So this is the possible structure for this question. Yes. Now let me prove how. So there is no peak splitting. Yes, there is no peak. See, no peak splitting. This would have three peaks splitting. Yes, there is three peak. This would have three peaks splitting. Yes, there is three peaks. So this is the structure. I can write this as well. CH3O, CH2, CH2, Cl. So this is the answer of this question.